Yeah, we can try it out. Recording started. So welcome everyone, especially you, Sean, of course, all the way from Davao. And everybody knows where that is, of course. one of one of the biggest cities in the Philippines. And you're gonna talk about the constructed wetlands that you do. Of course, we know each other quite a lot. Your last name is Ligtvoet. That doesn't sound Philippines. Maybe Sean, if you do a short introduction on who you are.
Okay, well, I'm Sean Ligtvoet. I work for the Department of Science Technology Region 11. That's in the Philippines, in the Mindanao region. That's actually Davao region, so all the way in the south of the Philippines. And I came here as an intern for my water management course back in 2012. Then I fell in love with the company or the country, and then I started making a prototype vertical flow constructed wetlands for the DOST, the Department of Science Technology, and that actually really took off. So when I had my thesis, I was doing also more research on the applicability of constructed wetlands in the Philippines. And when I graduated in 2016, I came here for 1 month. But now, 8.5 years later, I'm still here. So, and doing a lot of projects every year. So, also, it's this year actually, we are also doing a project in Indonesia via Blue Deal Indonesia. So that would be the first time outside of the country. But
Nice.
my presentation is more or less about the projects that already have been implemented in the Philippines.
Nice. Yeah. You have a presentation, of course. Maybe you can start with sharing. And of course, you have the connection in Davao. That's not always very good. So let's keep it try. And maybe shall we give, while you set up the presentation, maybe a short introduction of Sydney on the Climate Cafe?
The other people that are here, yeah, we can do a short introduction. Yeah, I'm Sydney Steeks from Nijmegen. I have a background in ecology and water management. Actually, constructed wetlands were one of the first ecological things that shifted my interest to the more civil engineering part. And I'm working for the municipality of Nijmegen now, yeah, from the engineering division. Working on bioswales, where I also know Floris from, and we're doing this Climate Cafe together now for a year already. Right. Next.
Perfect. And then maybe Ruben from a German train.
Sure. I'm Ruben. I'm studying urban development or spatial planning in Groningen in the Netherlands. Last half year, I did my internship at the local government unit of Mandawi City in Metro Cebu. And now I'm working on my thesis, which is on wetlands in Mandawi City. So that's why this
connection sorry to interrupt you, Ruben, but the connection is too bad.
Yeah, the connection was a bit, and I hope Sean is still there, actually, not sharing the screen, but and out of the camera. So let's check if the connection is quite good. Oh, he's still there.
Then last but not least, we have Shanae.
Hi, I'm Shanae Turon. I'm one of Floris's researchers at the Hanse, looking at climate adaptation. I feel like my experience is
switch to my microphone.
Can you hear me? Yeah. So my background really is civil engineering, and then I moved more to the environmental side later years when I did my master's, my PhD, concentrating on climate adaptation and climate change modeling, that kind of thing. Yeah.
Nice. Okay, then can you start sharing, Sean? Let's see if it all works.
Yes. So it's a PowerPoint presentation. What do I do? A window or entire screen? Because if I do it on window, let's see.
Entire screen would work if you have one screen.
Yeah.
I always choose that one. Yeah.
All right. Okay. Then let me know if everybody sees me now.
You see your presentation? Yeah, it's still in the presentation. Yeah, we see it.
All right.
Perfect. Yeah.
I cannot see myself then, but that's fine. Okay.
No worries.
So yeah, like I said before, I'm Sean Ligtvoet. I work for the DOST Region 11. We have also a few other partners. Centered on the top, you see also the University of the Immaculate Conception, which is our partner here in Davao. They have a good laboratory equipped with all kinds of equipment to do research on all relevant parameters set by the Department of Environmental Environment and Natural Resources in the Philippines. Then I'm also part of Help Davao Network, which is a UNESCO funded network in Davao. And recently I'm working with Blue Deal Indonesia, and we always have been close with Rotterdam University, who sends interns, free laborers, every year for different types of researchers. Also in the Davao City, the local water supplier is the Davao City Water District, which we have many projects with them. The DENR, who is the monitoring agency, and Aquafit, which is the private part of me, a private business. So this presentation is about vertical halophyte filter systems and enhanced hybrid constructed wetlands. So vertical halophyte filter system, I will right away say that's our terminology for the vertical flow constructed wetland, which we have enhanced in the Davao region. So our project, it's What's Up, a wastewater treatment system upgrading program. And then this is a video. I don't know if you can hear the sound. I will shut it up. Okay. So this is an informative video actually about the technology we are using for those who don't really know what a vertical flow constructed wetland or an enhanced hybrid constructed wetland is. So in this video, we are using a public toilet facility as an example, but this can also be a slaughterhouse, a hospital, an office building. But for the constructed wetlands, it's mostly the same. So because this is a public toilet facility, we are now showing a 3-chamber septic tank, which is the minimum requirement in the national standards. And that's always required to have in front of a vertical flow constructed wetland. So you always want to have the water anaerobically treated before it goes to the constructed wetland, as it is a secondary wastewater treatment. Also to remove the sludge and the scum from the wastewater. So in the last chamber of the septic tank, we install a submersible sewage pump, which is regulated by an automatic pump regulator. So this is very simple. This is just a breaker, a timer, and a magnetic contactor to prevent the wiring from heating. And mostly there's a floater switch as well. So the pump, it runs every hour for a couple of minutes, depending on the size of the filter. And it pumps the water to a main irrigation line in which smaller irrigation pipes are attached. These irrigation pipes are perforated, so the primarily treated wastewater is evenly distributed over the constructed wetland. Then this is where the terminology becomes different, because the DUST Region 11, we have actually made our own formula of filter substrates, which are locally available, and therefore we changed the terminology from vertical flow constructed wetland to vertical halophyte filter system for patenting reasons. So, however, the water is still flowing vertically through the different layers of soil, and in the lower portion, we put PVC pipes. Can differ from sizes. Mostly it's 3-inch, and we perforate them, cover them with gravel, and then we cover the gravel with a non-woven polyethylene geotextile, so the drainage pipes do not get clogged up. So all the water that is now passed through the wetland goes to the outlet, and this is actually where we can make it a wetland. And this is also not done too many times or so often, but we always increase the water level 70 to 80 centimeters above the water the bottom level of the filter, so the plants will have more time to extract the minerals from the wastewater, as well as aerate the water, because the halophytes, they transport oxygen through their hollow stems to the root system of the plant. So it's a very good nature-based aeration system actually. So the water that comes out of this vertical flow constructed wetland is already crystal clear and odorless. However, clear and odorless doesn't necessarily mean clean in the Philippines, where actually we hold very strict guidelines for our effluent standards. So in case of a poultry farm, hospital, slaughterhouses, and even beach resorts, phosphate, nitrate, and ammonium nitrogen are part of the relevant parameters that has to be lower than, for phosphate, it's less than 1.5 milligram per liter. For nitrate, less than 14 milligram, and ammonium nitrogen, it's less than 3 milligrams per liter for B-class standards, so where the people would swim. So in this case, we always include a horizontal flow constructed wetland, because it's just less expensive to construct than a vertical flow constructed wetland. But it's still, because it's more of mineral removal, we use the plants to to absorb more of the phosphate and ammonium nitrogen. And then the horizontal flow constructed wetland also is an area where denitrification takes place. So yeah, the water that comes out of the horizontal flow constructed wetland, that can safely be discharged into the natural environment. However, it's also being used for fish ponds and flushing out pig pens in slaughterhouses, and washing motorcycles and stuff. So they use it for that. So the combination of the vertical halophyte filter system and the horizontal flow constructed wetland, we call enhanced hybrid constructed wetland. So yeah, this is in Bisaya, by the way, Bugang, Tambu, Walis. These are very traditional Filipino brooms, and these are actually made out of the plant that we use, which is the Pacmatas carca, giant reed. And then this is me in 2012, so that is yeah, long time ago. 12.5 years ago, I was working as an intern at the DUST Region 11, and this was like my prototype back then. Of course, we we have it now made it a permanent feature at the DOST and enhanced the design. In 2016, I came back to the Philippines. I graduated, and there the DOST asked me to make one design for a small enterprise, which was Porky Best. It's a very famous meat processing facility in Davao. And then we made this prototype with a roof on top, so in the measurements there would not be any interference with heavy rains, so we could really see how the VHFS on its own is functioning. And here you can see the water is crystal clear, and then the water coming in, it's really turbid, and it's good that you cannot smell through the through webcam because it smells horrible. But this project actually jump-started the whole adaptation of constructed wetlands in Davao region. So our next projects were the Rivera Medical Center. This is a private hospital in Panabo City. So this treatment system of 200 square meters is capable of treating 14 cubic meters of hospital wastewater per day. Then we also deployed the 600 square meter vertical flow constructed wetland for the Maha Slaughterhouse, which is a AAA slaughterhouse, the biggest slaughterhouse in the whole of Davao region. Actually, the biggest slaughterhouse in whole Mindanao. And then we were asked by all the other slaughterhouses to build similar treatment systems. So one of them was this enhanced hybrid constructed wetlands, which we have installed in Santa Tomas. This is a smaller slaughterhouse. Also for bakeries, we have deployed these wetlands and then incorporated into the facade of the factory. So it all looks nice. Swiss Deli in Davao, which is owned by Swiss people. This is a very famous restaurant in Davao, and we deployed this 70 square meter VHFS. It's not only for the restaurant, but they also have a meat processing facility. Then Syntec AgriBiocorp are one of our largest projects so far. So this is a 700 square meter enhanced hybrid constructed wetland for an egg layering farm. And here you can see the filter system without the plants and then with the plants. And by giant reed, I really mean giant reed. These plants, they grow more than 20 feet, so that's more than 6 meters tall. And poultry farms and slaughterhouse are actually one of the most common projects we do. This one is a standard design we have for broiler farms, which hold approximately 250,000 heads. So broiler farms is where the chicks become chickens. They just grow there. And the interesting part is that they only clean it out once a month. So it takes 28 days for the chicks to develop into decent sized chickens. And then after they grow, they harvest the chickens and they clean it at once, taking approximately 5 days to clean all those chicken houses. And then in 1 day or in 5 days time, 250 cubic meter of wastewater is being discharged. So we mostly make a very huge primary treatment that can accommodate all the water and then irrigate the constructed wetland just little by little each day. So this one is only getting approximately 5 cubic meter of wastewater per day. This design is also being used for public markets in the Philippines. Public markets in the Philippines are different from what you expect that we have in Europe. They are really the place where all the people will go to buy their meat and their vegetables and their fish. Therefore, there's a lot of water being consumed there for washing, and all of this water can be treated by these systems as well. One of our latest projects is again for slaughterhouse, 300 square meter vertical halified filter system for the Nabuntaran double A slaughterhouse. And another poultry farm. So the reason why we use constructed wetlands in Davao is because for the DOST point of view, it's nature based. So what happens is that a lot of these companies they are forced to comply with national effluent standards. There's no such thing as a common communal sewage system or communal wastewater treatment system. So everybody that wants to have a business and discharges more than 5 cubic meters of wastewater per day has to do it on their own. Well, this is problematic because a lot of these companies, they tend to use a lot of chemicals to treat their wastewater, and we don't really know yet what are the long-term side effects of using those kind of polymers for the treatment of wastewater. And this treatment system is all nature-based. So aside from the fact that it can treat the wastewater very well, it absorbs massive amounts of carbon dioxide, and it's a very good habitat for endangered species like king cobras and some lizards, which are actually getting endangered now. But that's also a downside, because every time you do maintenance, you should really have protection, because there's always a deadly snake in there. However, most of our clients and the beneficiaries, they do it because it's low cost. So our system, we deploy for a very competitive price, sometimes 10 to 12 times less in the first 5 years of operation than any other technology. For instance, we had that project for Syntec for the egg layering farm. The lowest bidder was 20 million, and our system was only 2.2 million. For Swiss Deli, the lowest bidder was, I think, was 5 to 7 million pesos, and ours is 375,000. Now, this is in pesos, so let us say that 5 million would be 120,000 euros. And our system was only built for less than 8,000 euros. It's very low in maintenance, because the filter system actually only requires maintenance in the first few months because of invasive species. So you have to cut them out, and the rest of the system can just remain for years before you have to unclog pipes. So sometimes we just come there once a year to work on it for a couple of hours, and it's all back to how it was before. And it's very high performance. So definitely in the first couple of months, you will see that there's an immediate impact. Sometimes for the nutrients or the heavy metals, it takes longer for the filter system to filter it all according to national standards. But definitely after 3 to 4 months, it's already performing according to national standards, and only increasing its performance over the next years. You can see some of the results we got from our project at the slaughterhouse. So our expected output is is based on a lot of data we have collected. We have collected thousands of samples over the past 8 years to test these filters. So B-class limits are actually the limits that's being suggested by the DNR in Davao. So we always comply with these standards. Aside from helping out businesses and public facilities, we also try to do something for the urban poor communities. or for the rural communities. So we have started a public sanitation hygiene upgrading program. This project was the very first one in Barangay Pulcana, which is along the Davao Gulf. So these people, they did not have any public toilet whatsoever, and then they resorted to defecating in a plastic bag and throwing it into the bushes. It was horrible to walk there. It so many flies, and you can definitely smell what's going on there. So we put this toilet facility, six doors, because at the back there's also 3 for the women at the back and for the men at the front. So the water from this toilet facilities goes to an underground sewage or a septic tank, and from there it gets pumped up onto this 15 square meter vertical flow constructed wetland. However, we increased it after a year to 30 square meters because there were way too many people using this facility. They came all the way from 50 meters far to use this this toilet facility, because there's also not so much water in the area, and this facility also has this massive water tanks. So this really is one of my favorite projects, and we also constructed them upstream in rural communities. This was funded by the Department of Environment and Natural Resources. So we also did that for these people here. But the problem was that we also deployed a few of those systems, and then the community didn't really embrace it. So doors were stolen, lights were gone, even toilet bowls were chipped off and taken away. So that's why we actually had in a few cases we had a lot of capital loss, which is a big problem in the Philippines as a developing country. So now we actually make them semi-portable. So I came up with this design and then fabricated that with our team, and then we deployed them for geographically disadvantaged communities. So really up in the mountains. This was installed for a national high school, but actually more used by a tribal community which lives right next to it. So overall, we constructed 35 units so far, 30 adopting agencies, because some of them, they keep coming back, which is always good. So some LGUs have adopted multiple systems as well as private partners. We have constructed over 4,000 square meters of vertical flow constructed wetland, treat approximately 375,000 liters per day. And as of today, we have treated more than 500 million liters so far. Our upcoming project is this one for the regional government center, where all the government agencies will make use of this system. So this will be somehow a centralized sewage treatment system, the first in Mindanao, because the city government wants to decongest the downtown area, and therefore all the government agencies will move to a little bit outside of the city. And they asked me to make a design for the wastewater treatment system, which is this design, and it's already approved and just waiting for funding in 2026. So here you can see that the primary treatment is centered inside of a big constructed wetland. This design is also made together with professionals from Dutch water boards. So I've made many contacts now, and they are helping me out with designing the primary treatment. So this is my contact information. If ever you would like to ask more questions, but not via the interview, then you can do it by emailing me.
Nice.
So that is my presentation so far.
Thank you so much, Sean. Yeah, very impressive, all the work that you've done. Yeah, and of course, I had the privilege to visit some of these projects, and yeah, quite rare in Davao. Even Ruben, who's here in the call, has been in the Philippines, but I know that Davao, because I think there are even more than 35 projects, right, in the region. And you added them to ClimateScan, and I thought there were even more.
Yeah, there were 30. Yeah.
Oh, okay. Yeah.
But some of them, they're in the same farm. So, and then
all right.
took me much time.
Yeah.
Yeah.
No, but it's really impressive because I haven't seen them in Manila or Cebu, for example. Has that to do with legislation as well, or are the companies obligated to use purification, or how is that for companies? Why would they implement this?
So to go to the first part, we did deploy in Pampanga, which is just above Manila. And we also deployed them in Oriente Mindoro, which is a little bit lower island from Luzon. But in Manila, it's an issue because even in Davao City itself, the urban environment, land space is very expensive nowadays. So this filter system requires land space. So people would more or less opt for compactor systems, even though if it's much more costly to implement, the land space would actually outdo it. So that's why we are mostly focused on rural communities or agricultural businesses. Yeah, because then the land space is cost next to nothing. So then it's just very cost efficient for them to use this technology. Yeah,
perfect. Yeah. So we started already with Q&A. Yeah.
Even though we have actually a couple of filter systems in Davao City, but they're just for smaller enterprises.
Nice. Yeah, very good. Yeah, maybe opening the floor for questions. I'm sure Sydney has some.
Yeah. I already had the same question as you. Why is it implemented here so much? But it's practically answered now in more ways, because you also said it was really strictly obligated, and there were strict norms set by the municipality. These are, of course, all these things that are really helpful. But what I was wondering about is that. Well, at least in the Netherlands, I hear a lot of negative talks about halofit filters and constructed in the wetlands because of the maintenance and the unpredictability of it, for like when it's raining a lot, or when or that the input flows are still changing. And actually, here in the Netherlands, we had one constructed wetland and a halofit filter that was owned by people themselves, and they are stopping now because there's too much variation in their output. And I hear I hear like two sounds always in the Netherlands, like sometimes good sounds, especially through other projects that Floris Bogert knows. But on the other hand, I hear failure, and actually. The reason that it's not implemented is what you always said is in the Netherlands is often space is a problem. But that one I understand, especially in the Netherlands. But the other ones, I'm really skeptical towards actually this negative feedback about it, because now again I hear a story of no problem, it's cheap as hell.
Okay. Well, I think. We had one student that went. I'm not gonna disclose to what constructed wetlands he's been, but he went exactly what you said. He went to the Netherlands. he's a Dutch student, so he first saw all these filter systems in the Netherlands, and then came to my projects, and then like, why is that so clear, and why is it working so well? But I think in some cases they make things too complicated, and then lacking on certain other points. It's like you need to have a very good type of substrate. So we are using also things that are very expensive in the Netherlands, but dirt cheap here. So we use limestone, pulverized limestone, mixed it with very high grade sand, very coarse sand, and we keep actually the substrate always very, very coarse. Then we also use cocoa fiber and other enhancing substrates to remove the pollutants for the first couple of years. And all in all, we do make our systems extremely robust and permeable because I studied water management, so you have a little bit of hydrology and now how this would work over the long term as well. So this is I'm more on the engineer than I'm actually on the researcher side. And I have to admit, of course, we have many times that things didn't work out. We have a few projects for fruit processing companies that it didn't work. The water was just way too acidic. And then we also have so many people coming still. Oh, we have this mango processing facility, pineapple processing facility. And we say, no, we're not going to do it anymore because then the plants will just die. Another thing, I think, it's also in the Philippines, it's hot, it's tropical.
Yeah, I was wondering about that already. Yeah,
very,
the temperature.
Bacteria growth goes extremely fast, and in the Netherlands, everything dies pretty much in the winter. So if you would take a good amount of dirt with a shovel out of my filter system, you would be amazed. Like it's every square inch. It's like there's 100 different types of organisms. It's just constantly moving and moving, and that keeps it very much alive. So I've also thought of that seasonal differences in the Netherlands might have way more impact than the literature actually says it does. In Indonesia, for instance, I saw many filter systems that were also not functioning. But that was because of very poorly sourced substrates, which already initially contained a lot of loam and then finer silt particles. So you really do not want to have that initially in your filter system, because then you will just get too much biofilm stuck in the first layer of the filter system, and then it's just gonna get stuck up. So that is very important.
What I hear is like you guys over there have a lot of experience. You think like an engineer with a little bit of science added to it, or the other way around, which is like a formula for people to fine tune this whole wastewater treatment system. And that's what I hear from your story. That's the key in trying to fine tune it, search for the best substrate, the best flows, and that kind of stuff. And I also think, so this is not a question, but just what I think, that because in the Netherlands, the alternative is, just threw it in the sewer and we got rid of it. There's not really an incentive here to try to find, at least least incentive, to try to get so specialized that you guys compared to you guys are. So it's nice to see, because maybe someday those knowledge will go to the Netherlands, and we will be convinced more. But the seasonal thing, that would always be an issue. Interesting. I was thinking about the temperature, that it also helps, higher temperature for maybe higher rates. I'm not sure if I'm
but
if that's really true.
You could also say, okay, I've seen that before. They did it in Portugal, lower parts of Argentina. They make a greenhouse.
Yeah.
And they just put the filter system inside of a greenhouse. So that would also be another way how to keep that temperature going and keep that.
I think in Hungary they also have some kind of system like that, and they keep the temperature high up. But then, of course, you need to keep the temperature high up. That's another thing. Yeah. So there's
and that's
still
a wastewater system and actually a recreational thing as well.
Yeah.
So people walk through the wastewater system, and that's in Europe. So that's
I
quite
did
surprising.
read that they also had some issues from time to time, and that they also say, well, it's not the perfect solution, but it's really a nice one, that's for sure.
Yeah.
And I will have one question about the last project you show. You said, this is the primary wastewater system constructed in a wetland. I think this is an open door, how we say it in Dutch, but they are probably connected systems, right? You are using the primary wastewater system, and then as a secondary system, it's the constructed wetlands.
Yes, exactly.
Yes.
So it's a series of conventional technologies prior to the vertical halified filter system. It's also very important to know. I think a lot of people actually underestimate the importance of the primary treatment. So I always say I'm a constructed wetland expert, but we also focus a lot on the primary treatment, how that should flow, and what would be the capacity of that, and even post-treatment. And also what you said before, the fine-tuning. We constantly innovate, and we also get students from the Netherlands. So last time we had the student, he was focusing on more on phosphate removal in the hospital, because that was our issue, that fluctuated all the time at the hospital. And then he found out, because I'm not a chemist, he found out that there's different types of phosphates, which is normally not so common, but in the hospital it is, because they have all this very synthetic binding of phosphates in the detergents and in the medicines and stuff like that. So these kind of phosphates were a lot present in the filter system, and were very hard to remove with vertical flow constructed wetland. So we actually introduced a simplified calcium struvite reactor and the post-treatment of the filter system, and then that actually worked like a champ. Then now it's all steadily complying. So it's always learning by doing. Then and then keep on inventing more, and then seeing where the problems may arise.
Yeah, cool. Nice.
Absolutely.
I have a question. Actually, two questions actually. When you were looking or showing the videos of the outlet, there were two videos, one where the water was kind of just trickling out, and then one where the water was coming out quite a lot. What is the difference between those, and what is the retention time in a system like that?
Oh yeah. Well, actually, that with the water was quite a lot. Yeah, that's because that is actually the same filter. So, but what we did is we flushed out the vertical flow constructed wetland, and that is much higher than the horizontal flow. So if we flush it out, then it will bypass to the horizontal flow. And that's why that in that particular video the water was so much. But normally, and that if that is so much, then that should not be the case. That's too fast. So, but it actually can still run out pretty fast for larger filter systems. Definitely, if they're 600 square meters and above, then you really see a full 4-inch pipe, at least for 1/4 being filled and flowing out. So, but the retention time inside of the vertical halophyte filter system is approximately 2.5 days. And then in the horizontal flow constructed wetland, it's only 1 day. So, yeah. So that's also how we compute the size. So based on 4 different aspects. What kind of industry is it? Because then based on the industry, the government will assign relevant parameters. Then we will see what is in place with regard to the primary treatment. In some cases, there's zero, there's nothing. It's just straight from the source to the canal. And in other cases, they already have an incredible system, but it's just not complying. So we just add a little bit of treatment to it. And then it's also the location. If it's in a protected water or in an agricultural area, and then the volume of water. That those 4 factors decide on how we design our treatment.
Okay.
But in the slaughterhouses, the retention time is actually almost 12 days, including the primary treatment. So
would you say the slower the process, the better the quality water?
Yeah, well, yeah and no. It would be good if it's there for maybe 2.5 or maybe 3 to 5 days. But if you leave it there too long, you also have somehow stagnated water in the lower portion, and that is also where coliform would all of a sudden starts building up. So so it has to somehow also flow properly. Yeah. Okay. For the primary treatment, for sure, the longer it stays, the better. But the thing is that you cannot build it that it's going to be there for 3 months. Then you need an immense amount of space or depth to realize that it's becoming not feasible anymore.
Yeah, because that's what I was thinking about. All these locations, they all have different volumes that they offer, different flow rates. And what I also hear a lot in the Netherlands is that the amounts are just too big to try and build to treat it with a constructed wetland. But I think that's like your daily job, looking what's the input and then start designing on that, right?
Yeah, but sometimes actually in the literature they would say 40 liters per square meter per day, but for our slaughterhouse we do 150 liters per square meter per day, so that is actually quite high. Then again, it's all about also how to design the primary treatment, because you really want to have the sludge gone, and the oil, fats, and greases has to be removed. If definitely oil and grease, that will not degrade fast enough, and then the upper layers of the filter will clog up, and when that's happening, when you constantly see water on the top of the filter, then most likely your laboratory results will show that it's not complying, or worse results than before. So that is all about also designing that primary treatment properly. But that you said that my day is actually I design them and I also construct them. So I actually work on the excavator myself, and then I have a team and I install all the pipes and source out the plants.
But that's perfect. That's perfect for someone who designs, because that's often maybe lacking. Like here in the Netherlands, like for me, I'm currently designing, but today was actually one of the first days in I don't know, maybe months that I'm into the sewer system, but the first day in months that I open the sewer manhole again just to look at how it, because it's, yeah, I'm not, I'm making a design and then whoop, to a company that makes it, but for especially for these kind of systems that are of course way more complex and fine-tuned on the location, on the business, I think it's really good that you do that yourself.
It's very important that each and every, it's very simple actually, but you just have to do it right.
Yeah.
I used to work in the kitchen, and it is my chef used to say, cooking is very easy. It's all a series of very easy steps, but you have to follow the steps, and you have to taste it constantly, actually. And that is the same with constructing these wetlands. Like sometimes you see that then you get sand with the excavator, and somebody would get a whole scoop of this loamy dirt in there. And if I'm there, I would say, no, get it out immediately. And then the dogs, they will go inside. There's a lot of stray dogs. They will poop in the fields. Okay, get it out. And if there's sometimes things get damaged, repair it. And if you have an external contractor, that will be like, yeah, whatever. They will not notice. And then that's where the problems are. So it's every project is kind of like my child. I need to make it raise it properly and then see it work.
That's really that's really nice thing, and that's actually one of the things I heard here, how to fix the problem also in the Netherlands, because also maintenance of these systems in the Netherlands is often reviewed as it's hard, it's tricky. Like you said, something gets in there and the whole thing is messed up. But I also had some suggestions that some companies should start that design them, make them, but also maintain them themselves. And that might, I already thought so. I didn't know for sure, but I think that's the only way to do it for a kind of system like this. Nice. Really nice. I had one more question before the end. You also were constructing these kind of systems for agricultural areas, right?
Yeah.
En dan nou, ik kan even niet het Engels woord akkerbouw versus veeteelt en dan akkerbouw. Just plant agriculture. Are you doing it for those kind of systems as well, or just for animal?
We also have for rubber factory.
Rubber factory. Yeah, but that's more the industrial kind again. Now, I was just wondering, like, because on agricultural areas there is a lot of space. I'm thinking in the Netherlands a little bit, and they have often issues with water management these days. I'm just wondering if there are possibilities for that.
The Netherlands would be very great because of the ammonia crisis, right? The ammonium nitrogen.
Yeah,
they call
exactly.
It stick stop, but
actually
always ammonium nitrogen. So these filter systems have like a 95% reduction at minimum. So sometimes it's 99. There's nothing left. So I was also thinking that would be a very good solution, and they can be very easily implemented at the farms along the waterway, and that will also make sure that the cows do not fall in the waterways.
Same problem. Okay, thank you very much.
We should probably close up soon. Maybe good for Sean. Ruben had some connection problems. He is actually going to Mendau as a graduation project to work on wetlands, or basically wastewater treatment. So he will be in touch with you with more questions. He really loved it. And on the app, some people couldn't make it today, as Rick and other people as well. They will watch back this episode, of course. So because a lot of thanks. We didn't mention that, but it's past 12 o'clock in the Philippines, and that you give this presentation at a late hour. Yeah, that's fantastic.
Make me start talking about wetlands. I can do another hour.
Well, maybe next time we will invite you another time. Yeah.
Especially if you completed the project in Indonesia, for example, with the Blue Deal, maybe inviting also Water Authority to this. So that's really great. Yeah, thanks again. So maybe look forward to next week. Do you want to share, Charnay, who's coming?
Yeah, well, we've got Neil Armitage, who's going to come talk to us a bit about the downside of permeable paving.
Yep.
Yeah, I'll also share that specifics with Sydney. I don't know if you want to put it on the schedule. So
It's already on the schedule.
Oh, okay,
I put
great.
it on, yeah.
Okay.
Because as mentioned actually by Sean as well, the maintenance is mostly about clogging and
Yeah.
geotextiles with permeable pavement also in wetlands. It's the main key. If it clogs,
Yeah.
that's a bad design, so to say. So that's amazing because this was a wish for a lot of people to have some international knowledge exchange. So we're going to South Africa, we're going to the UK, we have been to the Philippines, but also Germany, and I'm forgetting one country. We'll go back to that. What's the other one? Germany. No, Germany, UK,
Again.
and then okay. So we're going to visit a lot of countries. So yeah, thanks again. I would say, and well, catch you next week. And have a good sleep, Sean.
Yeah, thank you very
Thank
much.
you.
All right.
All right.
Everybody.
Bye.
Thanks again. Bye.
Bye-bye.
Nah, cool.